This presentation examines the use of graphical models in general to illustrating economic concepts, and the use of the production possibilities curve in particular to illustrate the concepts of scarcity and opportunity cost. Before we get into the specifics about production possibilities curves, a few words about graphs in general. Graphs are picture representations of numerical data. Economists use graphs for two basic purposes. First, economists use graphs to show change over time. The graph on the left shows how the temperature in New York City changed over a 6-day period. The vertical axis of the two-dimensional graph shows possible temperatures between 0 degrees Fahrenheit to 80 degrees Fahrenheit. The horizontal axis of the graph lists the days. To plot the various points on the graph, all I need to do is trace upward from the day I am considering and across from the temperature associated with that day. Note this same information can be displayed in a table as well. Second, economists use graphs to illustrate relationships. A graph on the right shows the relationship between price of a good and the quantity of the good that would be purchased at each price. You'll note that in this particular graph there are no specific numbers. Instead, there are simple representations for numbers like P1 and Q1. P1 and P2 and Q1 and Q2 do not have to have any particular numbers attached to them. All that is important to note is that P1 in this case is higher or greater than P2 because it is higher on the vertical axis, and Q2 is greater than Q1 because Q2 is to the right of Q1 on the horizontal axis. Movement up on the vertical axis or to the right on the horizontal axis are both associated with an increase. The green line or curve illustrates the associations of various prices with various amounts that would be purchased at each price. And there are an infinite series of other points between A, B, and C. The point of this particular graph is not to demonstrate the relationship of for any particular good, but to show the relationships for goods in general, or all goods. The downsloping curve or line indicates that we can expect an inverse relationship between price and quantity purchased. That is, as price goes up, purchases go down, and as price goes down, purchases go up. The concept illustrated by this graph is called the law of demand. It shows the relationship between a change in price and a change in the quantity demanded. The graph here is called a production possibilities frontier, or a production possibilities curve. Like many economic models or graphs, the production possibilities curve illustrates general concepts. In this case, the concepts illustrated are scarcity and opportunity cost. Opportunity cost means simply that in a world of scarce or limited resources, we must make choices. We cannot have unlimited amounts of everything we might possibly want because the time and economic resources needed to fulfill those desires are limited. In this simple model, if we want more trucks, I will have to settle for fewer boats. There is an inverse relationship between the number of trucks that can be produced given a fixed supply of time, resources, and technology, and the number of boats that can be produced with the same time, resources, and technology. The green line shows that relationship. You note that same relationship is also shown in the table to the right. There are three assumptions behind this economic graph or model. The first, there is a fixed amount of available resources and technology. The discovery of new resources or the invention of new technology would change the position of the green curve. Second, the graph also displays data from a fixed period of time. Given more time, perhaps, I could produce more of each good. Third, there are only two products in this economy, in this example, trucks and boats. Again, it is important to note, the graph is not really about trucks and boats, but about scarcity and opportunity cost. In the real economy, there are virtually limitless possible goods and services that could be produced, not just two that can be illustrated in a two-dimensional graph. In real life, we are typically not confronted with a choice between this particular thing and that particular thing, but a choice among many possibilities. What this graph, and economics in general, teaches us is simply that we cannot have everything we want. We must make choices. And in making these choices, we are implicitly giving up something. That is the thing we did not choose. One thing you might notice about the production possibilities curve here is that the opportunity cost increases as you move along the curve. Choosing to produce the first 4,000 boats only cost the opportunity to produce 1,000 trucks that otherwise would have been produced. Transferring an amount of raw materials, human effort, and machinery as well as entrepreneurial talent that had previously been devoted to truck production to boat production meant we would have fewer trucks, more boats. This trade-off is represented by moving from position on the y or vertical axis at 10,000 trucks and 0 boats to position C on the curve at 9,000 trucks and 4,000 boats. If we wanted still more boats, we would have to transfer even more land, labor, capital, and entrepreneurship from truck production to boat production. Thus, we might move from point C to point B. But you will note that in moving from C to B, we gained only 3,000 additional boats and gave up not 1,000 trucks this time, but 2,000 trucks. Thus, we got fewer additional boats while giving up more trucks. Going from B to A, the opportunity cost of boats in terms of foregone trucks gets even greater. In order to get 2,000 additional boats, I had to give up 3,000 trucks. Finally, to squeeze out the final possible 1,000 boats that my economy is capable of producing, I had to give up the last 4,000 trucks, leaving me with no trucks at all. At that point, all available land, labor, capital, and entrepreneurship had been transferred to boat producing, leaving none for anything else. This works the other way around, of course. If you start with 10,000 boats and then decide to produce trucks, the opportunity cost of trucks will rise as well. You can check this out yourself by going from point A to C instead of from C to A as we just did. The reason the law of increasing cost is so is that not all economic resources, land, labor, and capital, are equally well suited to every purpose. For example, certain land is good for growing rice and other land for growing wheat. If I'm initially using all of my land for wheat production, I am likely using some wet, swampy land for wheat that would be more suitable for a crop that better tolerates or thrives in wet ground, like rice. If I want to grow some rice, I would logically start by using the wetter portions of my land for growing that rice. I will thereby give up very little wheat, since it did not grow very well in that wet land in the first place, and getting a great deal of rice. If I want all rice, though, I'll find myself in the end trying to grow rice on high and dry land that is not well suited for it. I will in the end find myself getting very little additional rice on this dry land that could have produced a great deal of wheat. Thus, the opportunity cost increases and my production possibilities curves for wheat and rice bow outward. Then there is inefficiency and free lunches. First, let's look at inefficiency. The green line in the graph represents all of the productively efficient possibilities. Productive efficiency means that in the given period of time, we're maximizing production using all available resources and the best or most effective technology. The green line illustrates possibilities, but not actual results. Rarely do we use all resources or use available technology. I might have factories or workers sitting idle and not producing anything at all, or working with primitive tools or inefficient productive methods or management. Thus we end up at point D on the graph. We get only 4,000 trucks and 4,000 boats, when with better use of our resources we could have had more of both. Also, the graph does not tell us what combination of trucks and boats we might desire. The graph does not tell us whether at points A, B, or C would best meet our needs or desires. This is a question of what is called allocative efficiency. Producing 10,000 boats might be productively efficient on the graph, but boats are of little use if you live in a desert and need trucks to move your stuff. Producing boats in the desert would be allocatively inefficient. Then there's point E on the graph. Point E represents an impossible combination of 9,000 trucks and 9,000 boats. It goes beyond the current production possibilities frontier. Point E suggests that there is such a thing as a free lunch. Much of modern government policy is based on the idea or belief that there is such a thing as a free lunch, that through the magic of government policy, we can all have free health care, free food, and free everything. Point E suggests that I can have all these things and not have to give up something else in exchange for it. Perhaps having access to high-quality health care is important, but is it more important than having a home to live in? Perhaps having a clean environment is important. But would I choose a pristine, clean environment at the cost of not being able to feed my family? Health care and a clean environment come at a cost. Economists cannot tell us what we should choose, but what they can tell us is that the very act of choosing implies a cost, an opportunity cost or foregone alternative. We must not just consider what we have or what we'll get, but what we could have had or what we would have gotten had we made a different choice. Now let's take something that hits a little closer to home, grades. Even these come at a cost. You are reading or listening to this presentation right now. This takes time, and that is time you could be spending doing other things that also have value to you. Let us assume, for example, that you have 20 possible waking hours in a day. The other 4, let's say, you must spend sleeping because it is simply not possible for you to stay awake more than 20 hours per day. For good health, of course, you need more than 4 hours, and let's say you need at least 8 hours of sleep each night for optimum health. Thus, if you choose to use the entire 20 hours you have available for studying, one of the things you'll be sacrificing is your health. You have other priorities as well. You want to maintain your relationships with your family and friends, and this means spending time with them. You also might want to earn some money and work, and this takes time, and you have other interests that take time as well. So what do? You prioritize. Based on your own values, you make decisions about how you'll spend your scarce time, first giving up things that have little importance or value to you, and then giving up things later that have greater value. You also take into account your individual abilities. If you are academically gifted, perhaps getting A's in your classes comes relatively easy for you, and does not require much sacrifice or opportunity cost. If you are not academically gifted, getting A's may require substantial investment of time and energy for you. Thus, the opportunity cost for an A for you might be quite high. Each person's production possibilities curve will look different. In our diagram, here you have the production possibilities for different possible grade point averages in terms of sacrifice time for a particular person. The curve represents the present capabilities with regard to grasping course concepts. The more time the person spends studying, of course, the higher the grades they get. But the return is not even over time. Getting D grades requires relatively little sacrifice in terms of time and thus other priorities. You need to study only, say, 30 minutes a day, and this leaves plenty of time for sleep, work, friends, and all the other stuff that is important to this person. Going from D to C, however, takes a bit more effort. Say an additional 1 hour, or a total of 1 hour and 30 minutes now. Going from a C to B, an additional 4 hours, for a total of 5 hours and 30 minutes per day. Then finally going from a B to an A takes an additional 8 hours, or a marginal increase of 8 hours, for a total of 13 hours and 30 minutes. This leaves barely enough time for sleep, let alone anything else. The person could even decide to get beyond the 92% required for A's and spend every possible hour studying the economics and other topics, but this would mean sacrificing health and sanity. Is the A that important? Maybe it is to this person, but who am I to judge? Again, the production possibilities curve represents what is possible and represents the cost. It cannot tell you what is appropriate or desirable. Only you can decide that for yourself. Of course, production possibilities do change over time. We discover new resources and improve our productive technology. In the case of our grades, we get smarter and develop better strategies for studying more efficiently. New learning technologies like the computer also make getting information easier and faster. These new technologies are sometimes called capital. Using a computer to get information more efficiently is an example of using capital. You might save some of your money to purchase a computer or capital in the future by sacrificing the possibility of using the money right now for, say, a vacation. You initially get nothing for this sacrifice, but in the future, once you purchase and learn to use the computer, the greater productive efficiency you gain frees up time for you to work additional hours and afford 3 or 4 vacations rather than just the one vacation right now, all while getting the same or even higher grades than before. This is the benefit of saving and investing for the future, rather than consuming potential capital for short-term benefit. Point A in the graph above might represent the inefficient use of your time, using ineffective study techniques. Point B on the blue curve would represent using the best study techniques available right now, and point C represents your achievement at some future time once you have the computer and have sufficient time and effort to maximize its effect. The red production possibilities curve lies in the future and is currently not possible, and of course would never be possible without the savings for the computer. Production possibilities can also shift inward if, say, the computer is destroyed in a fire. In a larger society, natural disasters or wars destroy people and resources, resulting in an inward shift of the production possibilities. Contrary to some economists, wars are indeed destructive and in no way beneficial to economic well-being. Wars, or for that matter natural disasters, do benefit some people, like weapons contractors and morticians, but only at the expense of everyone else. As Frederick Bastiat noted over a century ago, perhaps the glazier or window repairman profits from a broken window, but only at the expense of the shop owner, who has to pay to fix that window.